All right, one of the big questions that I think people ask is, how do you get the kids motivated? How do you get them there? They're taking a test, or even before they take a test, they're in school. How do you get them motivated to get excited about learning? You know, and the question is that, you know, the kids have other things to do and things like that. What's the process? So I think one of the things you have to realize is you got to get the kid to get passionate, interested in what they're doing. But you have to have them have self-esteem and say to themselves, wait a minute, I see how to do this thing. I want to go ahead and do other things. One of the big problems that we have in this nation is that people are looking at an all or nothing answer to everything. Kids take a test, and it's either right or wrong on the test. So when the teacher teaches the class and says, well, did you get this right? And the kid says no, and then the teacher says, well, this is the right answer. You want to get the kid so that the kid says, wait a minute, I thought I did something right, or maybe what I did is just totally wrong. I have to learn something completely new. If the teacher says, what you got, what you did, is partially right. You would, if this were a weighted answer test, you might have gotten some credit for that answer. So here's an example, and I see this personally all the time. You give a kid an example like, what's the average rate of a car going uphill at 30 miles an hour and downhill at 40, the same distance? And the kid chooses 35. Average 30 and 40. Now, the worst thing you could say to the kid, no, you're wrong. That's not the average rate. If you would have said, so look at the difference. If you would have said to the kid, you know something? You know what average was. You knew the average of the rates was 35. But the average rate, strangely enough, is not the same as the average of the rates. It's the wording. So the kid, now look at what's going to happen to the kid. The kid's going to say, oh, I did know something, and isn't that interesting? It's the wording that's changing it. So maybe the kid will even get interested in the wording, and interestingly enough, in grammar on the SAT, a lot of this is dependent on this sort of thing, is to see what's going on with the wording. And if the kid had that mathematical experience, the kid might even say, I'm going to try to use this experience in grammar now. So the idea is you want to get the kids to feel better about themselves, to feel they can do something. You know, everybody has potential, and this is what the problem is. We say to the kid, no, you're wrong. You're either right or wrong. I mean, when I got a 90 IQ on an IQ test, I could have gone the way of saying, because, you know, I was considered below normal. Because all you're saying is that you look like, you sound like you're below normal. No. But I looked at this, and I said, wait a minute, I wonder why I got a 90. I looked at it sort of almost objectively. Like, why did I get a 90? What's in that test that made me get a 90 on the IQ test? And then I realized, my father was a high school English teacher, so he got hold of an IQ test. He gave me the IQ test. Of course, he wanted me to do well on the IQ test, and that, he had a bottom line attitude at that time. I was kind of curious about what in that IQ made me get a 90. I looked at the questions and I said, gee, this is interesting. I could have done that with this question. I could have done that with this. The wording of this was very tricky, and I got fascinated with the test. I was able to increase that, and a year later, like to 126, and then later on to 150. Although, I'll tell you very frankly, which actually is positive, I feel like I still have a 90. So when somebody looks at me, and I see that they have and they say, well, I have 140 IQ, I immediately think they're brighter. But, you know what this did for me also? It made me feel less arrogant to everybody. I didn't feel authoritative. And the kids love this. I didn't feel like, oh, I know what I'm doing here and you don't. I felt everybody's smarter than me, so maybe they can learn something from me, and of course I might be able to learn something from them. That was and I felt this way, and I always look up at people as them being brighter than me, which actually makes me want to learn more. So, in a way, there are two things. The 90 gave me like the career I have, and also made me feel humble, which also helped the career. I mean, it worked in both ways. So the idea is for years I've been thinking, what are the key things? How do you get the kid to really get impassioned with learning? And how do you get the kid to look at a question and say, I want to solve that question? One major thing is you want to make sure they get involved with the problem. You don't want to give them the feeling that they just need to get an answer. I had an experience at Brooklyn Technical High School 30 years ago, and this is what scares me now, and this is why I think we really need to change a lot of this. At Brooklyn Technical High School, I gave the kids, I remember, a math problem. And I asked them to calculate the answer. It was a triangle, and I asked them to calculate a side. And they calculated it, but every one of those kids, this is Brooklyn Tech, it's a high-level school, every one of those kids was curious about what would happen if I changed the numbers in the problem. Would I get a different answer? You know, I mean, it's a curious kind of thing. Did that 30 years later at Lowell High School, right here, equivalent high school, just as bright, the kids are just as bright. Nobody was interested in getting a generalization. I said to them, don't you want to know if you change the answers? No, you just asked us for the answer. This is scary. And then, of course, the College Board now is trying to they're consistently dumbing down the tests. I can share, and it's very subtle. There can be a question where they'll say, based on the numbers, this is the case, and then they'll change that question, even though the specifications really should be the same when they make up another question. If there are odd numbers, if they're only odd numbers, what is the solution? So here they're giving the kids something extra because they feel the kids can't work generally out of it. And this is a very serious thing. We're now making kids, we're getting kids not to really think, but get to just, essentially memorize and not. So what I want to do is show some particular examples. I mean, when the core curriculum, let me just mention something about that. It's excellent in the concept. My personal feeling is I think it will not be instituted properly, or teachers are going to have a hard time instituting it. It's inherent with strategies. And I mean, I'm not bragging about it, but a lot of them are the strategies that I have. So it's something that can be really useful, except I don't know if the teachers, it's going to be coordinated properly. So just like with the new math. I mean, the new math in principle looked pretty good at first, and then it totally failed. So, but what you want to do is you want to get the kid to feel comfortable with something and to say, oh, I see why this is done. When one of the most powerful strategies in math, for instance, is in geometry. Where in geometry, when a teacher says, two sides of a triangle are equal, and let me prove the base angle is equal. And I don't know of any teacher that I've seen say to the class, the reason why we drop a perpendicular down in solving this problem is because it so happens that every time you draw a line, especially if it's symmetrical, you get something else out of it. And if it's symmetrical, if you make it something that looks like something is equal, you're going to get two equal things out of it. That is the motivation for drawing a line. So the question is, why, after geometry is being taught for so many years, why on the SAT there are questions where all you have to draw is a line down and you get the answer based on that, drawing that line, that maybe 1 out of 20,000 people get it right. Something is wrong with that. In fact, let's, if I can, let me start out with what I mean by a strategy. And let me mention something I'll mention a few things that are very specific, of course. Strategies, and this is a very key point, strategies enable you to solve a problem mechanically without getting into any panic. So just like I was up in front of an audience, and I mention this many times when I give these talks, but I think it's worth repeating again. I'm up in front of an audience, and must have been about 500 people in that audience. And most of them were teachers. And I made this day, I saw they were all tired. It was the end of the day, and they were all tired and wanted to go home. So I said to them, I said a very bold thing. I said, you know something? You give me any problem, let's say on the SAT, that can be solved by a genius in less than a minute, and I will be able to solve that problem on the spot here. And why I told them, I don't want to sound egotistical, but I said the reason why I can do that is because I know strategies. Strategies they're not the magic. There's something that you can figure out. Through a strategy, you can figure out almost any problem if you know all the strategies. So I was going to go on with the rest of the talk, and then some guy from the college board, I remember, gets up and says to me, okay, wise guy, we have a problem for you. We have here's a problem that is being field tested on a test, but it's been accurately resolved. We may use this thing, and want to see if you can solve it. It's one of the hardest problems on the test. So I was going to say at that point to the audience, well, let me go on with the talk. We only have an hour or so. Let's go. But I thought that's the worst thing I could say. It's like admitting that I said, okay, what's the problem? So it was coffee and espresso, a mix to give 50 pounds, and this, and this. How much coffee is in the mixture? And those are the worst problems, the mixture problems. Those are the brain-racking problems. But I knew what I tell students and what I tell teachers, if you use a strategy, you don't have to rack your brains. You just almost do it mechanically. I looked at the thing, and one of the key things in doing a problem is you want to extract something from the problem that leads you to the next step without worrying about the answer. I cannot emphasize this more. Do what Einstein did. Do what the great journalists do. They're interested in the process. Process. That's a big word. A very important word. Get something out of the problem that you can use to get something else, which reduces anxiety too, and gets a feeling like you want to go on with the rest of the problem. So I looked at it and I said, oh wait, coffee and espresso will give you 50 pounds. C plus E equals 50. I wrote C plus E equals 50. That's one equation. I knew from basic skills, which you really have to know cold. I mean, those things are like, what's an odd number? 2 to the 3rd times 2 to the 4th is 2 to the 7th. You don't want to memorize. You want to just memorize that stuff. I knew I needed another equation to solve it. That enabled me to look at what was given to me and look for that other equation, and I was able to solve it. And I told them that's how I did it. I said, at first, I was acting like a student. I got panicky. And I was thinking first of just rushing into the problem and just, even guessing at it. But then I used my own strategies. So the interesting thing about strategies, and I'd like to do one of these problems, was the strategies enable you to solve a problem without racking your brain, or even, I hate to use the word, without really even thinking that much. So if you're up and on a test, or you're in front of an audience, this is great for you to do. Now the interesting thing is, and this is what I find fascinating, it actually makes you interested in doing this. I was doing a talk for PBS once, and it was a seminar where who knows who was it. It was like, I didn't know who the audience was because this was a taped seminar, and all the people from the various school districts were listening in. And I was so, I didn't know, I got fired up while I was doing this thing. Robbery is to thief as something is to something else. This is when they had analogies on the SAT. And I started getting fired up. I'm thinking, am I crazy? You know how many times I've seen this problem? What's the matter with me? And then I said to the audience, I stopped. I said, let me analyze this. Why am I getting so fired up? I mean, wouldn't it be great if all teachers could get fired up when they do things over and over again? Or if you had a job and you kept on doing this job, you were bagging groceries or something, and you kept on doing this, and you kept getting fired up to, wouldn't this be fantastic? And I thought to myself, you know what's going on? It's almost like classical music, or like music. I'm looking at this robbery and thief and saying to myself, there's something in that I can work on, that I can solve the problem. I'm going to put it in a sentence. Robbery is committed by a thief. And let's see if I get something out of the sentence. Even though I've seen it before, that feeling, it's like listening to a piece of music again. That feeling is still the same. I can hear a piece of music that I've heard when I was a kid and even get more fired up now. Even though I've heard it before. It's the same music. Could be even the same performance. In fact, if it's the same performance, it might even be better. So the thing is that you want to get kids to feel this way. I mean, if I can feel this way after doing something 1,000 times, you want to get the kid to feel. So let me do an interesting question where only 65% of the California kids got this wrong. What percent of 5 is 20? And this is what happens. Kids will say, well, do I put the of over the is? Do I do this? And one thing, of course, is to use intuition and say, well, the 20 is a lot bigger than 5. But the only problem with that is, when you say the 20 is a lot bigger than 5, your intuition is marring. It's sort of like it's not letting you don't know what to go from there. You don't know where to go from there. You're not sure of where to go from there. That's good after you figure a lot of this out. So I'm not sure. The intuition will be developed after the strategies are. So now, if I said every time I see a percent, or let me first give you this thing. 65% of California kids got the wrong answer. The only one, 6%, got the right answer. Imagine 6% out of so many California kids, only 6% would get this right. Now, here's the strategy. Every time I see a what, I put an X. Every time I see a percent, I put slash over 100. Every time I see an of, I put a times. Every time I see an is, I put an equals. And look at what happens. And interestingly enough, you can do this with so many problems, and it's still exciting when you do this. I mean, I can give you some problems which are brain teaser problems, and if you do this, they're not that difficult. Now, there's another strategy that should be mentioned in schools. Whenever you have numbers like x times 5 over 100 over, like that, you want to cross off, you want to get rid of the fractions. You want to make it simple so it's on one line. So, by getting rid of the fractions, you get almost the answer immediately that way. Now, after this, interesting, after you get 400, then you might say to yourself, oh yeah, it had to be bigger than a small number but that's an afterthought. That's something, and that's good to keep, because then you get that feeling like, oh, that satisfies what I just did. And let me, while we're on this thing, and we discussed some of the strategies, let's do the, I should mention this. When 100 students were exposed to the strategy, this particular strategy, this was done in the San Francisco School District. The same, a different problem, of course. But it was the same type of thing. 90% got the correct answer. Or no, those students, I think at that particular thing, they didn't see that question, that other question. So, you can say, well, does it work? Well, yeah, there's the empirical evidence there. Now, what's the value of x in the diagram? This is a typical SAT problem, or an ACT problem. So somebody would look at that You know, isn't this interesting? I mean, I get fired up just by, and I've seen this again so many times, I get fired up just by saying, I want to show them how to do that. I want to show what I'm going to do this thing. I see that, and I say, how the heck do I find out what X is? What do I do with the 5 and the 4 and the 8? You want to. You have a diagram? Ed, what do you do?
I'm just holding him a 5.
Okay. You want to draw a line. Let's draw a line so that line. Now, notice what happens when you draw that line. You start getting a lot of symmetry here now. And when you do that, you find that one side is 4, the other side is 3. And now you can say to yourself, well, what do I do now? Okay, here is the basic skills issue. You need to know basic skills first. You know what I did in my books? I had purposely answered every question, especially in the math, with a basic skill and a strategy. So I said you use this strategy and you use this basic skill. Basic skills, you have to know code. So you need to have an understanding, and I even developed like 101 math questions that you need to know, which explains, describes all the basic skills. So you have to know the Pythagorean theorem, that 3 squared plus 4 squared is going to be x squared or 5 squared. But let's go even further than that. Why should you bother calculating the Pythagorean theorem all the time? Why not memorize certain triangles that relate to the Pythagorean theorem directly? There's a 3, 4, 5 triangle. Okay, a 9, 12, 15 triangle. So, these things you want to, learn code in this sense. So, the answer there then is 5. By the way, are there any questions in the meantime? Are there any? Okay. Let's, interestingly enough, I had many meetings with the college board on what to do with a new exam and stuff like that. And one of the things I brought up with them was that, I think that in math questions, you should be very careful on when to have a kid use a calculator and when not to. In fact, they're changing the question on the upcoming exam where there's only going to be certain questions where they're going to be able to use calculators and certain questions where they're not. And one of the things I mentioned, of course this is in my books also, they could have read it in the books, is that what happens, you don't want to get a kid to just rely on a calculator, just do things rote on a calculator. You want them to use a calculator where they would need to use a calculator. If I want to multiply 17 times 34, yeah, I'll use a calculator for that. But suppose you have a problem like this. As a matter of fact, the ACT, I remember, had a problem like this purposely because they wanted to see whether a kid would use the calculator and make a mistake. So you have 2/3 times 3/4 times 4/5 times 5/6 times 6/7. So let's say the kid wants to use a calculator for that. You know how tedious that's going to be? And there's a lot of room for mistake. So watch what happens. See, here you want to get this student to say, curiosity is a big thing. You want to get the student to say, what's interesting about that problem? What's curious? Every kid has this curious impulse. When they're children, I see with my nieces and my little kids, they're so curious. I could tell you stories about the curiosity, and it's just amazing. And then when they get older, somehow this starts getting lost. I don't know why. Their life is like going down. It's like they're getting older. It's sort of. I feel young, as young as I felt when I was, 80. No, I'm just kidding. I feel as young as when I was, 20 or so. In fact, I think I might even feel younger, because I still have that curiosity and that interest. So I see something like this, and this is what the kid should be doing. 2/3, 3/4. Whoa, there's a 3 in the denominator, or a 3 in the numerator, or a 4 in the denominator, or a 4 in the numerator. Oh my God, I can just cancel those. That's all I need to do. And what do I end up with? 2 7s. Now, look at the interest that a kid would have if they saw something like this, instead of doing something in a rote fashion. You know, I mean, let me just mention this story because it was very impressive. My little niece, who at that time must have been about 5 or 6 years old, and she was drawing little alphabet, little things like A, little C, big C, and all that. I got curious. So I said to her, how many letters do you think have the same small letter and it looks like the same big letter? Like little c is just small and big C is big. R and R are different. The R is different than the little r in looks. Right? The X is the same as a little x. And she said, she started to get interested and look at all that. And then I said to her this, and interestingly enough, I said this to an older person, they didn't even get it. I said to her, what about the P and the P? She said, oh no, the P is below the line. That's a lot different. You have to put the P below and the P is above. This is brilliant. I mean, a little kid, 5 years old. I did this with, I was even curious about doing this with a teenager, like a 17-year-old. They weren't even interested, let alone thinking the P and the P. This is a very serious situation. This means they're losing a whole bunch of interest, this curiosity. Let's go to another question. Now, this may be a little more esoteric, but this is a standard SAT question. If x plus y is 7 and xy is 4, find the value of x squared plus y squared, where x and y may not be integers. Now they may have it where they are integers to make it a little easier. And many kids would say, well, I don't know how to go from one to another. I don't know how to relate the x squared plus y squared. If you would say to the kid, get a connection between x plus y squared is equal to something else. A translation in math is a big thing. If you can translate something, like if you asked me what 100 times 100 minus 99 times 99 was, somebody asked me this on a radio show. And they said, what's 100 times 100 minus 99 times 99? And they said, would you try to use one of your strategies to see if you can get it? And at first I thought, and then I thought, wait a minute, translate this. Let 100 be x and 99 be y. And sure enough, I get x squared minus y squared. And that gives me a translation of x plus y times x minus y, and that's 100 plus 99 times 100 minus 99. And I just get 199 as an answer. I mean, it's these things, you know. So, the same way as somebody once on a radio show once said to me, where do you get the word consider from? It's how you figure out, because I'm talking about prefixes and roots and meanings of words. How do you know what the word consider is? Well, how do you figure out what that meaning is? I thought, this is a question that's not prepared for. I mean, I thought, well, con means with, but of course that doesn't give you the answer. What could consider be? And then I thought, wait a minute. I knew astronomy. I studied astronomy once. And there's a thing, sidereal time. So that's probably where that SID comes from, time. And I said, is it time? I wasn't sure, but I took a chance. And the guy said, yeah. That's another thing I want to mention. Chance taking is very important, except you have to know when to take the right chances. I mean, you have to be prepared with strategies. I was prepared because I knew that sidereal time meant that. So I took that chance. A lot of students wouldn't do that. A lot of students and adults would be afraid. They would say, Oh, no, I know sidereal time, but nah, that couldn't be it. You know, but they have something there. It's not a matter of, it's not like roulette or something like that, or just gambling where you don't know what's going to happen. So that's, you know, that's another thing. It's a chance taking. You take a chance if you feel you got something there. Here's a very simple problem with one of the simplest problems that if you don't know the strategy, you will not be able to get. You have a circle and you have a rectangle inscribed in there. You want to find out the radius of the circle. Does anyone want to see if they can get that?
So what are you saying? You know the radius?
You don't know the radius. You know that that line there is equal to 5 inches. I know the radius of the circle is 5 inches. You want to find what that line is. You know the radius of the circle is 5 inches.
So you know the radius.
Yeah.
And you don't know the dimensions of the rectangle.
No.
So you're saying any rectangle has the same diagonal?
The two diagonals, well, you got a point. The two diagonals of a rectangle are the same. Is that what you're saying?
Oh, I see what it is. I know.
But if you drew the radius...
I see.
Yeah, if you drew the radius, you'd see it's the same as the other line.
Exactly.
So that's probably the simplest question about using a strategy for solving that. Should we... Oh, I wonder if we should explain this. You tell me whether you want me to do this. Here's a question that about 6 out of 1 million people got right on the SAT.
Really?
Yeah, it was some low number. I don't know if it was actually 6, but it was some tremendously low number.
Oh, this is this problem.
Yeah. Now, this was the problem. That was the problem. Now, the strategy is to draw a line. So let's immediately draw that line. And what I get from drawing the line, see, the beautiful thing about strategies is once you use a strategy, even though you're going to say to yourself, I don't know if that'll work, once you see something come out, which will happen, then you want to go ahead with the problem. It almost motivates you to go ahead, just like it motivates me to talk about this because I'm seeing this work out. It's like classical music or music. I mean, I see it work. I see it's working out. It's almost like nature is doing it, you know. So if I draw that line, I start breaking up. I get various triangles. I get x plus y plus b plus c plus c equals 180 for the big triangle. This is the sum of the angles of a big triangle. Of course, that's a basic skill. You got to know the sum of the angles. The internal angles in a triangle is 180 degrees. Add up to 180 degrees. Then a plus b plus c is 180. But now I say to myself, well, how do I find out what a is in terms of x, y, and z based on that? And here's another powerful strategy. This is why just a few out of so many people got it right. There were 2 strategies involved. One was, of course, drawing the line. The other thing is when you have 2 equations, instead of solving for the equations, like substituting this and putting it in that, as everybody is taught to do, or people learn to do. I learned to do this thing. There are 4 things you could do with equations. You can add the equations, you can subtract the equations, you can multiply the equations, or you can divide the equations. So I'm tempted here to say, wait a minute, I have 1 and 2, I have x plus y plus b, I have this like this. Why not just subtract the equations in this case? And you'll see when you subtract the equations, you end up with that. So interestingly enough, see, these strategies make you feel not only interested in doing the problem, but make you feel comfortable with doing it and get you more excited about the process rather than the answer. And we have to keep getting away from just the answer. I want to become a lawyer because there's lots of money in law. And then you get into law, oh, I can't stand this. I don't like the logic of this. I don't like what's going on here. But if you went into law because you liked the logic, or you wanted to change the logic, or you felt like you had a mission like that, that would be a lot different. I mean, I like this stuff. When I finish a book, I'm actually disappointed. I mean, you know, it's nice, you make the money off the book and all that, but I'm disappointed in the fact that it's over with. I've done the book, I put the interesting things in that I thought were interesting in it, and now it's over, it's in. It's like I listen to a piece of music, you finish the piece of music, it's over. Oh, you have the memory of it, that's for sure. But that experience is over, and interestingly enough, you will not get that same exact experience. You might get something similar. And luckily with strategies, you get almost the same thing. I mean, when I do another problem using a strategy, I still get fired up. So it's in a way maybe even better than music that way. Because that performance may not be the same when you hear it again. So let's go on to the verbal thing. Suppose you have a sentence completion. By the way, sentence completions will be taken out of the new 2016 SAT exam. But for now, let me do it through a strategy because the thinking will still be the same. They're not going to destroy the strategies on the exam. They may destroy the actual, when they took out vocabulary antonyms, they still had vocabulary in there. And they still have vocabulary in the new exam. So, being something person, he insisted at the conference that when he spoke, he was not interrupted. You want to get the feeling of, well, what does this mean? If you're some kind of person that doesn't want to be interrupted, what type of person are you? Are you a successful person? Oh, possibly, but it doesn't really relate to that. Are you a delightful person? A headstrong? Very, very possible. An understanding? Not really. A solitary? No. Headstrong is probably the best choice there. And notice how I did this. There I would say I did it through an intuitive type of thing. But I also did it just getting involved and feeling, what's the feeling of this thing? So key words are the important thing in something like this. That he insisted, very powerful word, that he was not interrupted. So watch for this. You see, you want to have on a test, and in life, I think, you want to have an active rather than a passive approach. Passivity is dangerous. First, passivity will probably not get you the right answer, but on top of that, it will make you feel lethargic. You won't feel like doing anything. You won't enjoy it, and you won't want to learn more. So you're losing a lot of things by being passive. The active approach is the way to, and how do you get active? You get involved with a thing. You don't have to go to the extreme that I did when a teacher, gave me a test. I remember this was in high school. Brooklyn Tech this was actually, and the teacher gave me a test in high school, and I saw one of the questions could be made a lot more interesting. So I said, if you would have put this word in and could have sort of changed this around, this would have been a real interesting question. The teacher comes over to me and he gives me a D on the paper. I said, well, what is a D for? He says, what are you, a wise guy? I know what I'm doing. You don't have to tell me how to do this thing. So my father came up to school, I remember, and complained about it. The guy, I think, changed it to a C. He refused to give me it. But that's okay. It didn't affect my graduation or anything. But, I'm not saying don't go as far as that. You can think that, but, being active, and that's why when a little kid is curious, they are active. And when they lose the curiosity, it goes hand in hand with being passive. It's like everything, and you know, computers don't help in the sense, I mean, they're great as far as, you know, like finding out things and, you know, I mean, I love, I'd rather work on a computer than a typewriter. But the thing is, you can't use a computer just to do things for you. You should be the one that uses the computer just for the information that you really couldn't get or couldn't get fast enough. You know.
Can I interrupt for one second?
Sure.
I have to go. I have to get back to Nobelitism, but I have to say I'm very glad I came up with it because now I really understand what your approach is, and I'll talk to you tomorrow.
Okay, great, great.
This is very, very useful.
Yeah, go ahead. I'm glad.
One thing, I'll be right back, so I can.
Okay, so move on.
I'll be right back.
Let me go on to. I'll finish up soon. I just want to. Let me just go on to. Yeah. Suppose you see words that you don't understand, and you want to figure out the meaning of the words. I think I mentioned this before, but inextricable, you look at the in means not, extra means extract. And as I was saying before, I think, you know, one kid was saying to me, well, you know, how do you figure out the meaning of inextricable? And first you could say, well, in means not, but then extra, so you use extra, not too extra. Now it doesn't make a word. So don't give up. Think about what the next thing. Not to extract, that does make a word. So you can figure out words. If you see a word like magnanimous or ebullient, those are big sounding words. I mean, magnanimous has magnify in it. These are big sounding words. Think of it being big. See, here's where you want to take a chance, but the chance is good. Now, if you have a word like, paucity, which means poverty or, you know, not having enough money or something, that may be difficult to figure out the meaning. And there I wouldn't take a chance because, I mean, I don't know what chance I can take. You know, what could paucity mean? But something like magnanimous or ebullient, effervescent, these are all big sounding words. So that's one way to figure them out. Now, it so happens there's a list of 34 prefixes and roots that give you the meaning of over 100,000 words. And I then expanded that by really looking at the words, and I found out with a 50 prefixes and roots, you can get 200,000 words. So that prefix and root list, I mean, that's, you know, like degrade. DE means away from. So if someone says to you, desist or detract, and you don't know what the word is, think if D means away from. So that's a negative sounding word. So the whole thing is going to be negative. See, you want to get your mind active, and you want to get to think strategically. And you'll actually enjoy taking the tests this way. Let's look at a writing example. Here's a typical example on the SAT. Which underlined portion has the error A, B, C, D, or is there no error E? Until the train stopped at the station, neither the engineer nor the conductor were aware that one of the passengers had become ill. So you think to yourself, well, is this the same as until the train stopped at the station, the engineer and the conductor were aware? No, it's nor. There's a nor there. There has to be a difference. So the nor is sort of like isolating. So it's like saying neither the engineer, only one was aware. So it has to be was, not were. See, now, notice something very interesting. I mean, in my books, I have a complete grammar of freshers and all that. And, you know, you can go to the details of, oh, this is the conjunctive, this is this. But you can also do this, and I also have it in the books, of course. You can also do this mentally or, you know, strategically this way. You don't have to memorize the grammar rules so much. You can just see what's going on. Here's another classic example. And this is a lot of students got this one wrong on the SAT, type like this wrong. Dr. Seuss, whose 44 books have sold more than 500 million copies, have made him probably the best-selling children's author in history. Now, this sounds okay, right? I mean, it sounds Dr. Seuss, have made him But look at what's interesting about that. This is almost like a mathematical puzzle. If I said, Dr. Seuss, if I left out the word, these clause, whose 44 books have sold more than 500 million copies, this would read, Dr. Seuss have made him probably the best-selling author in history. That doesn't make sense. So, but I don't need that who's 44. That's like a parenthetical statement. It's like saying, well, Dr. Seuss, whose books have sold more than 500 million copies have made him this. I don't need that clause, whose 44 books have sold more than 5 million copies. So by leaving it out, what would I put in there? I'd have to put Dr. Seuss is probably the best-selling author in children's history. Now, interestingly enough, when I show this to students, this type of example, they say, oh my God, I didn't have to go through the grammar with this thing. I don't have to learn these specific techniques. I can just do this logically. And this is what's so interesting about all the strategies. They're all logically based. They're all common. I was on a radio show once, and this guy said to me, after discussing, it was an hour and a half, and at the end of the program, the guy looks at me, not angrily, but he looks at me and he says, wait a minute. What you're talking about is all common sense. There's no mystery behind this. And I didn't want to tell him, hey, don't say that because I won't sell any books. But I said to him, yes, you're right. Now, the big question is, why don't people use common sense? Why don't they see? And I think it's because they're taught to memorize at a very early age. They're taught to regurgitate things. And they're not taught to think of maybe this is the process. And the kids start losing it. And then what happens is that the curiosity gets lost. So you're getting a combination. It's almost like a virus. I hate to say this, but it's almost like a virus that keeps getting bigger and bigger, and this is it. And then the kids say, "Oh, well, I got to get into this school, so I got to, just memorize this stuff. I got it." So all of this is like becomes enveloped this way. And what's the ironic and the unfortunate thing is, the kid loses self-esteem. The kid loses interest. And what's worse is the kid loses passion in doing what they really want to do. So, I mean, and if I get a call from somebody, it warms my heart when somebody says years later, some of the strategies that we went over is the reason why I became a medical doctor. It wasn't because I wanted to make money off the medical profession, although the person was making a lot of money. It's because I enjoy the intricacy of seeing how the process works and why things happen the way they do. And it's not just the answer. So, the thing that I think, out of this talk, that I hope you'll get out of is that process is a key element. And how do you do, not answer. Einstein was actually, people don't believe this when I say this, but this is true. Einstein was actually disappointed when he got the solution to a problem. He actually was depressed. And when people asked him, well, what's going on, Al? I don't know if I said Al. He said, because I was so engrossed in the process, and now the process is lost. It's the end. And now I have to go on to something else. Fortunately, I'll go on to something else that there'll be another process. But it won't be the same process. So I've lost that particular thing. So, it's sort of like, you go to a party, let's say, and you enjoy the party tremendously, and the party's over. The process is over. Luckily, you probably enjoyed the process of the party. But what's happening now is the kids and the students don't enjoy the process. That's the danger. And then what's going to happen, I did an article recently called Dumbing Down the Nation, and that's very serious, whereas I think what's going to happen is that people aren't going to think. They're going to just want the answer, they're going to refer to a computer for the answer, and who knows if the computer is right. I got to tell you this, in maybe closing, or that I was shocked at this situation. This has nothing to do with the SAT. I heard a song called Save Tonight. Eagle Eye Cherry was the song. I happen to like classical music, but I also like rock and other music too. And Eagle Eye Cherry was about a person that was with a woman and had to leave her in the middle of the night because he had to go somewhere else. And nobody knew where he was going, whether he was going to jail or whether he was, who knows what. And I looked at a blog on the internet. And there must have been hundreds of people writing in the blog. Well, did he go to jail? Did he do this? Did he do this? And nobody, knew the answer to this. And I thought, wait a minute. I am so curious. I mean, people hate when I do this. When I'll see somebody in the street that I think I know, I will ask them, do I know you? And people that are with me will say to me, this is embarrassing. I mean, they may be... I won't sleep that night if I don't know who that person was. So this Eagle Eye, let's get back to this Eagle Eye Cherry thing. I then called up the producer of Eagle Eye Cherry in New York. The guy was in Sweden or Finland, I think, the Eagle Eye, the person himself. I said, I've been very curious. I've seen a blog about this. I've been very curious. I sort of told him who I was, and I write books, so he thought there was some credibility in why that I was kind of curious mind. And I said, could you find out what that song meant, what he meant in the song? And sure enough, he writes me an email back, almost a few days later. Contacted Eagle Eye Cherry. He says when he was a kid, his father left him to go on tour to various places in music, I think it was. And when he got older, he did the same thing. He was with somebody and he had to leave them immediately to go on tour. And that's what the song was about. Now, the thing that gets me, of course, I'm satisfied that I got the answer. I wouldn't have slept if I didn't know the answer. But why did not one of those hundreds or 1,000 maybe people do what I did? Why didn't they call up or find out where's the initiative? Why weren't they curious? They were curious. They were writing, and there was some curiosity. They don't go to the step of, and I feel it's because they don't feel that they're equipped to do that, or they feel like they may be reprimanded by doing that. So the self-esteem issue, you want to get the student, this is the most important thing, get the student to feel good about themselves. Everything they do, every student I work with, any little thing I see in the student, I say that's, if it's, something is usually there, and I say, yes, let's use that to go on to something else. Let's get something that you have positive and let's go on, and that kid's self-esteem shoots up. And that's what we need to do. We need to get kids, even though they get the wrong answer. That's why I proposed to the College Board many, many years ago. They didn't take me up on it because it was too costly for them probably. I said we should have weighted answer tests. We should not give a kid an all or nothing answer. If a kid gets we should give partial credit for answers. So then the kid, when taking the test, says, I'm not worried about getting an all or nothing thing because life is not all or nothing. I want to, if I know something, that makes me feel good and I'm going to go on. And we need to get the kids to do this. And frankly, one of my missions is to get the nation so that they feel that they can do anything they want. Their self-esteem is up. And I think we'll have a lot less crime. We'll have a lot, people are intelligent. That's the thing. When someone says, well, no, I'm stupid or I can't do this, you can extract something from anybody and get something out of it. I can't tell you how many experiences I had with somebody saying, well, the kid is very dumb. You won't be able to help him. And I'm working with a kid, and I see something that's almost brilliant. And I'm thinking to myself, why didn't someone see this? So there is something, you can always do this. And I wish there would be, like a coordination of people making an effort, like this. Thank you for inviting me here because I have the opportunity to say this sort of thing. And this is, and I think that once that's done, once we get the kids' self-esteem and realize that they can do anything, and even if they get a question wrong, some part of it is right, or they can use something in it that's right. Don't give them an all or nothing thing. They'll want to go ahead with the rest of the problem and maybe do well in life as a result. Well, thank you very much.
not actually sure how it works. Alex? I'm not sure how it works. Do we
No,
put this on
I sent you a
our
link.
website?
I sent you a link. Then.
And then I can forward that?
Oh, well, that's great.
Good.
This was, I told you, this is firstly, got me connected with the Montgomery Cemetery. I was the keynote speaker. The next speaker that we was at, and got me speaking to the short term. Together. 6 people showed up at this last event that I spoke at in Lexington. But I was at 4 different classes, and they wrote it all up when I speak at the
Okay, so then once
Okay.
all right, sure.
Your relationship.
That's okay. This is good, you got it.
That's right. And you solidified that.
And then once I get those nowadays, people will send it to the information online.
That's
and
it.
send it to them. Yes. Gosh, if only I had known before my kids took the SATs.
I wish I knew myself before I.
Yeah. I avoided it.
Well, this is like a lot of
Oh, it's fascinating.
Who's recognized on her.
trying. But it's not.
6 people showed up. I spoke before the school video for the arts, and the kids on our district courses, and they wrote it out. He was just he wants to partner with
I appreciate what you're doing. I appreciate it.
He did get it.
I always said, I mean,